All right. Well, thanks everybody for jumping on our call today. We're excited to have a presentation ready that I got to see at least a version of somewhere in the last year at a small regional meeting that we hold over in the Rocky Mountain Advanced Computing Consortium group. But we're pleased to have Scott Sir from Idaho National Lab today here to present on the NodeMan, a node management tool for HPC. So I'd like to turn the time over to Scott and let him get us going.
Can you see that okay?
Yep.
Great. Get ranged a little bit here. Okay. Yeah, thanks for giving me the opportunity to share this project. My name's Scott Sear. I've worked at the INL for 8 years and as an HPC system administrator. And I'd like to share NodeMan with you today. It's a tool for node management on HPC clusters using a framework of bash functions and GNU parallel. And kind of the flow I wanted to use today is, provide some motivation for what I've done, some of the solutions that I've used in the past, and some problems with those solutions. Kind of the way I was looking for a better approach and some examples of how I use NodeMan or have created functions in NodeMan. You can see I did get it released out on GitHub. So you can peruse the source code and examples a little bit there, and I'll get going. So I found myself doing a lot of tactical tasks at the node level, and maybe if we have some people in the on the call that deal with older systems and a lot of nodes, they can commiserate a little bit. A lot of failing hardware, mostly motherboards, CMOS batteries dying. We had probably 100 CMOS batteries die in a year in this cluster of 500. Thermal paste issues, and kind of the standard power outages, cooling, and so on. And we transitioned from Bright to Werewolf. We weren't using Bright probably to the fullest that we could have, but Werewolf is, pretty bare bones as far as monitoring and reacting to issues. So maybe that was part of the reason that this project started. And my manager gave me a 30-day stretch goal, which was basically do something that you normally don't do. So, something to improve your life. So this was kind of the genesis of this project. Hopefully there's some people on the call that are system administrators and they've used pdsh and clush. Here's some examples of how I use both. An example here is get a list of all the motherboard models for all the nodes in your cluster. And so you can do something with it, right? You can say, well, in my case, we had a number of motherboard models that were different out of 500 nodes, which they weren't necessarily supposed to be different. Heat up a rack with LinPack, run it in parallel on a rack. Let's see. Yeah, count how many times storage was not responding on each node and sort that by count. So yeah, some interesting ways maybe to use Clush to get some information off of your cluster. But I also do, a number of one-liners and scripts. So here's probably, yeah, this is something I found in my bash history. So you don't you, you don't want to try to parse that with your eyes. It's not a lot of fun. So when you go back and you try to reuse anything and it looks like that, it's a mess. And another thing that I'd like to note is Clush does not have this feature here, the PDSH-W dash. Basically, the standard out of a of some command piped to the standard in of PDSH with the dash here. We'll treat this as the host list. So you could operate on certain hosts, a set of hosts, and run that command on them. And so Clush doesn't have that. It's kind of a they have a different idea of how they want to design it, and I don't think that they could do it. I think they're passing the standard into the processes instead of using it as a host list there. So this is some tactical work that I do. I could probably use the word tactical a lot in this presentation. I need to know which nodes meet certain criteria and then often do some kind of action. And we did this a lot before before this tool too, with scripts or one-liners, uh, a lot of SSH or Clush or PDSH, you know, which nodes don't have apps mounted. We might need to reboot them or mount apps. You can see some other examples. Grab the service tags of systems with memory less than a certain amount because they probably have a DIM that's failed, or don't have a DIM possibly, and then maybe don't have the desired firmware. Well, we want to offline them with a reason in the scheduler and upgrade the firmware. You can say probably a lot of these things could be done, with good node health check rules, and we're getting there. But then there's some things you just don't foresee. So my world was a bit messy, of course. Scripts. Should I make a copy? If I need a new script, new functionality, should I make a copy or should I leverage the old one and try to extend it? A pile of one-off scripts where for a lot of systems. And then there's kind of the one-liner, and you've done something similar in the past, so you're grepping through your history, saying, "How did I do that again?" Um, so I thought of this idea of a node management tool, which would be less ambitious than a cluster management tool. Focus at the node level, and it would be kind of, I find myself needing a tool that falls outside the the realm of provisioning and scheduling and monitoring, um, kind of an ad hoc Swiss Army knife. I did mention the NHC stuff. So I really was frustrated that Clush didn't have what the old PDSH had. So I want that -W dash to read a node list. And I wanted to be able to interoperate with shell commands like sysadmins often do, right? And then I wanted to be able to access all kinds of things, not just things through SSH. Clush and PDSH uh, tend to just go through and run things on nodes. So more, more of my desires is a low barrier to entry, familiar to sysadmins and let them start working right away. Rapid prototyping and ad hoc use, and compact and expressive to hide the details. So here's, I thought of a collection of shell scripts or functions that work together. You can see that's kind of a while loop just rolling through a list of hosts. It's natural, uses standard in, standard out to do that sort of thing. You could also do something like this with pdsh or clush. And I guess there's it needs to, whatever I do needs to be fast like pdsh and clush. So I was aware of GNU parallel and I started playing with it. You can do things like clush with GNU parallel and SSH. You can also do things, whoops, you can do things outside of the SSH sort of commands, like using IPMI tool here. In parallel, you can go fetch the RPMs of all your fans, for example. So kind of the pieces started coming together for maybe making a real tool. So here's kind of the first NodeMan function that I built, that I remember anyway, was kind of a network health check. Just, can I ping all the interfaces, the InfiniBand or OPA, whatever fast fabric here, and then the Ethernet, interface, and then the BMC of a host. And you can see that the body of these two, the while loop and the GNU parallel, are identical. And it's really the fluff around it, the while and the parallel, that are really any different. And I found this kind of neat hack where you can embed a function in a function in Bash. You kind of do have to export it so GNU parallel can see it. But this basically calls this function on any hosts that are passed into parallel as standard in. And before I go any further, I guess I should ask if if there are any questions so far.
Feel free to unmute and ask questions verbally or throw them in chat. There's also a spot in the call doc you can write questions out in if you've got them, and then Matt and I will help keep Scott aware of any questions that get put there.
Okay. And so here's some, I'll kind of continue on with some examples of the use here. And so you activate it in kind of a similar way that you activate, say LMOD or Conda or something like that. You just source it. And then it starts with nm dot, so you can hit tab to get a list of the commands. So you can see here, nm nodes sends a list of all your nodes in your cluster to standard out, but that's all it does. And you can get a list of anything that cluster shell clue set is aware of. So here I have groups set up, of course. That's how people use cluster shell, is they create groups. So rack 1 is a group, and it will output basically all the hosts that are in rack 1, right? So you're able to construct, a pipeline of these host names, pipe them into a command. So of course this is pretty simple. The NodeMan uptime just runs uptime on the individual nodes. So any nodes being passed in over standard in are going to have output of the uptime. So this is not that interesting, but this is kind of interesting. NodeMan, or sorry, the nodes function sends all the compute nodes to the fan load function. And the fan load function gives me the fan RPM and the load of the system. The fan RPM is coming from IPMI, and the load is coming off the OS. So two different sources of that information. They're collated together and thrown as a line in the output.
Scott, there's a question in the chat.
Okay.
Wants to know, how did you find the thermal paste issue? Were there certain errors in the IPMI event log, or visually check the CPUs?
Excellent question. And I might have that on the next slide. Maybe not. So we did notice that we were having some thermal paste issues. And one of the things that we can do is look at D messages for thermal throttling. And so I wrote a function to pull those out, and another function to count them. And so systems that had a high number of thermal throttles in the last couple of days, then those were targets to go look at their thermal paste. And I can actually show that function to you here in a minute. Here's a kind of a use where you can pass in a list of hosts, get the firmware on all the firmware on those hosts, and then collate it with clueback. So it says, okay, all the hosts that I passed in, all 10 of them, they have identical firmware. And you can kind of take some guesses. So if you just grep for the BIOS in that last output, you'll be only looking at the BIOS. And if you collate that, then you're going to get any mismatches in just the BIOS firmware. So it's kind of a slick way to reuse the same functions. And it's kind of the Unix standard in, standard out sort of way to do things, right? And then here's a sick function. You can imagine that it just produces output for nodes that have an issue with either the BMC interface, the fast fabric, or the Ethernet. This third item here gets the logical proc, which is what Dell calls the hyperthreading in their BIOS, and if that's disabled. So this would have hyperthreading turned off. So you're going to get a list of all nodes with hyperthreading turned off here. And as I went along, I started using rack ADM commands, if people are familiar with that. So you can actually do commands in the iDRAC with rack ADM. So I can turn on the hyperthreading on nodes. So this is basically just a wrapper around rack EDM to do that. So we in this system we have a 4-in-1 chassis. So we have 4 nodes in one chassis. And so this neighbors and me will give me the neighbors inside that chassis of this compute node. So I'm starting out with just one node, pipe that into here, and I'm getting 3 other nodes in addition to the one I sent in that are the neighbors, and checking to see if they're in use with the scheduler. So I know if I can turn them all off, or basically offline them and say I need to do some work on that chassis.
Wow, we got another question in the chat.
Okay.
And it's NodeMan seems to overlap with a lot of existing tools and seems to have similar philosophy to parts of XCAT, Confluent. What projects, rather than individual commands such as flush and pdsh, did you consider before writing NodeMan?
I'm probably, yeah, go ahead.
He just finishes off with, and why did you choose to create a new rather than contribute to an established effort?
Maybe because I was ignorant too. Or maybe because it's fun to create projects or create working systems. Yeah, I would like to see like XCAT and did he say Fluent? I'm not familiar with that.
He just has Confluent wrapped in behind XCAT.
Okay.
Confluent is a spin-off of XCAT that Lenovo is managing.
Gotcha. Yeah, I'd like to look at other things, see if they have other, good features. When I'll probably, yeah, I guess I can say this right now, is another thought that I had is integrating these wrappers of functions into node health checks too. So kind of giving me the freedom to either run things in this pipeline or kind of restructure the code a little bit so that these are, kind of first class checks in a node health check system. Yeah, so here's one where you could grep out of your scheduler's output offline, firmware update, see if the firmware was good, and then online it. And the previous one was get the nodes that are free that are not in the schedule, not being used in terms of resources in your scheduler, and then if they need the firmware, offline them and update their firmware. So this, you can chain together as many commands as you'd like, and the longer they go and reboots happening in between, the higher possibility there is for a problem. But I have tested some of these to the point where some things work, like this long pipeline here. I'll just talk about this real quick. Check rack 1, look at the power status of some of the host names, or the hosts, and get their system event log and the roll-up information. And if the health information on the node is error, I want to offline it and start troubleshooting. And offline it with the reason that I'm troubleshooting also. Okay, here's probably, yeah, here's the example I was thinking I had. So look at all the nodes, look for thermal throttles in the D messages, check and also see if there's been a battery failure and offline those nodes with the reason change battery and reapply thermal paste. And you can see output the service tag information for a list of nodes and so on. Here's one I can power on nodes slowly with a 0.1 second interval and shuffle those so they're not turning on all in one rack. You know, it's spread out through your whole cluster. And so that's kind of a wrap up. I'm probably a little early, but we can look at some more examples on the GitHub page and take some more questions. Okay, I'll just start talking a little bit to the GitHub page here. It's under Idaho Lab NodeMan, which you probably saw earlier. Just have a brief description and some basic ideas of how you might use it. Kind of some reasons that I like it. You know, there's no libraries, no GUI, no database. You know, pretty much you just have to have GNU parallel and clustershell and IPMI tool and have host names implemented in some methodical way that clustershell knows about them. And then hop over to examples here. And you, like I said, after you get it installed and sourced, nm tab for file completion. Here's an example of just getting the chassis tags. Say you want to document those or save those off or send them to the vendor. Here's an example of seeing if the network is sick on nodes. Zeros, return of 0 is good, 1 is bad. So you can see that this node here has a problem with the BMC. And the other two nodes, their BMC is working fine, but they are probably not booted. They're probably not in a booted OS because their Ethernet isn't up and their fast fabric isn't up. And one thing to note here, this line here is standard error, and the ones with sick is standard out. So if you add to this pipeline, the standard out is going to the next command, and that host name will be processed. So the front end of this line will be processed. It throws away everything after the colon. So if you're creating a pipeline, you can stack these, and that's how it works. The host name is assumed to be before the first colon.
Hey, Scott.
Mm-hmm.
There's a pair of questions that are similar.
Okay.
Curiosity is, where are the node sets defined? How do you maintain the inventory?
Yeah, that's in clustershells. I believe it's like /etc/clush/group.d or something to that effect. So there's configuration files where you define what a group looks like. And so you could define something that looks like this and call that, rack 1. I'll show you kind of a neat thing. Once I got this working, I can get the boot mode, which would return UEFI or kind of the traditional old BIOS, legacy BIOS. I can't remember exactly how that's designated there, but they're different. And I actually found nodes that were in a different they were gateways, if I remember right. They were actually in a different mode than I thought they were. They were shipped to us and set up from Dell, mismatched. So you find things that you've lived with for 4 years and then figure out that maybe that's why they act a little different. Yeah, I have ways of getting the thermal profile, maximum performance, or I also am able to set the thermal profile. Identity on and off. So if you have a list, for example, you have a bunch of nodes in your scheduler, you could grep those nodes out that have a certain reason and turn the identity on those easily. So it's just, a real nice shorthand way of doing many different kind of disassociated commands. Yeah, I think that's probably, you know, the idea here. I don't really have a whole lot more.
Maybe I'll throw out a question. As you've gone through this, you've got a lot of these functions and capabilities that you've built in kind of around things you bumped into day-to-day work. How often do you find yourself adding more at this point?
All the time, really. I can explain a little bit how the project's structured too. So there's when you set up your site, your cluster, you would uncomment out, say, PBS versus Slurm. So you would import in the Slurm type um, functions there if you uncommented that out. And for example, if you have 4-in-1 chassis, this is applicable. Or Dell, if rack ADM specific commands, you would uncomment out that and get that functionality. And what I think is neat is, just your average HPC sysadmin that doesn't know, say, programming languages. They can pop in here. They can go. This is one I added, task clear, just a few days ago. We had an accidental update of a bunch of firmware, and all this is on a newer system. It's 843 nodes. And I wanted to clear out that firmware update on anything that hadn't updated yet, but I didn't want to do it in a bad way, like rebooting systems or anything. I just wanted to talk to rack ADM, and I just basically wrote this function within, I don't know, 2 or 3 minutes, copied kind of the template from another function, and then knew that I wanted to pass rack ADM job queue delete dash dash all. And so I ran that over the whole cluster, which killed off any pending IDRAC tasks. If there's, I guess the one of the important things here is, you know, you can make it your own, right? It's not, it's not set in stone. I might not have the best ways of doing things, and I'm also happy to hear of ways to make it better, or if there's another project that I should have been using, that's important to know too. But you can see, you know, it's very simple, very straightforward. You're depending on parallel and this function to do the job. Let me see if I have. Here's a good example. So firmware updates. I basically want to do as many in parallel as possible, but also delay so that a little bit between starting them, just so I don't have all the systems trying to do their update at the same time. And then a 20-minute timeout. If running this script up here takes 20 minutes, I don't want to wait around for it anymore. And line buffer basically means continue on. Let's see if it, I guess, send the output independent of the other parallel tasks completing. So maybe this is a little bit of a crazy way of doing things, but it's served me well on these Dell systems. For example, I can push my self-signed SSL certificates to the IDRAC with this command. And so I think maybe I don't. So kind of a process of blessing a new motherboard, a replacement motherboard into the cluster is first get SSL working properly with the rack ADM command. So I do that here. Then I set the BIOS settings to a kind of the golden copy and update the firmware. And I can do that all with these NodeMan commands.
So there's a question that was dropped into the chat a bit ago. When you listed the software, or even beyond what you listed, do you need to install any of the packages or software on the client nodes, or is everything just on the management place?
Yeah, basically it's all on the management. You know, really all I need on the client is an SSH server listening, and some of the tools that are run right on the client. For example, dmessage, of course, you know, for scanning the dmessage output on the client. But the list of tools are only needed on the server. And I guess one thing to note is it's very helpful if you have your server on a network that can talk to the BMC and the fast fabric and the IPMI on your clients. Otherwise, if it's like a hop like we have on one of our systems, Sawtooth, for some of that connectivity, I'm kind of working on that. I'm thinking about ways to solve that problem, where IPMI might not be exposed everywhere, which is probably good in a lot of ways. But you know, or maybe your fast fabric isn't exposed to your server. So those kinds of checks are harder to do. Kind of need a satellite server or some way to do an SSH hop through.
Maybe then another question is, as you've developed this, has this kind of become mainstay then, kind of within the whole systems team you have there at INL?
It's pretty new. We've talked about it a bit here at the INL. It's since I'm the admin on the systems that could utilize it best. And Kelly, we've embraced it. Also our technician has found it really helpful because he's able to do you know kind of these high level commands that don't have a lot of details exposed that he has to know and understand. I'm working with him a little bit, and want to get him familiar with just adding in his own functions to expand it to make modifications. So I guess one thing that I'd say is it lends itself, at least in my mind, to you know larger node counts. I don't think you're going to want to run this on a dozen or 2 dozen systems just because you don't have the problems that people have with 500 or 1,000 systems. And then if you have a great solution already in say monitoring or scheduling or like an integrated cluster management system, maybe this isn't right for you. This is kind of down in the trenches, tactical kind of tool to give you answers when you can't get them other ways. Or do things. Yep.
There's another clarifying question, Scott, around the package installation piece. So someone asked on the machine running NodeMan, is it GNU parallel, clustershell, and NodeMan itself that are needed?
Yes. Yes. Yep, right here. And I do have an install doc here that kind of walks you through setting up all the requirements. There is GNU parallel. You have to agree to cite them if you use them, which I do. And then kind of doing the initial setup. Let's see. I don't think I have. I'm planning on talking a little bit about setting up clustershell, but I don't see that I'm doing that yet. But there's a little bit of setup as far as what your cluster name is, and what systems can kind of auto detect. Say you'd want to run these commands from your Slurm server and your Werewolf server, for example. And then including the bits that are appropriate for your cluster. And you do have to have IPMI user and password tucked away somewhere. You can edit the code where you'd like to find that, but I kind of came up with a good mechanism to do that. Yeah. Yeah, and even give you a little bit of a walkthrough on just how to cite GNU parallel, or agree that you will cite GNU parallel.
There are other questions people have or comments they'd like to share.
Looks like Paolo's got his hand raised if you're ready to go.
Hey Scott, thanks for your presentation. I'm curious, did you mention if you have other folks in other centers playing around with this, or is it just at Idaho?
It's just Idaho National Lab for right now. Yeah, I guess you can see that a lot of a lot of my initial commit was a month ago. So it's pretty new. I've been working on it for about a year and a half. Kind of formalized it into something that we could release on our external GitHub. Just late last fall, early winter, and then was finally able to get it out here.
So there's another question in chat, is when using GNU parallel to run functions like this, do you have to take into consideration the resources on the head node? Do you need a large amount of cores to get it to work? Maybe even memory kind of considerations.
So right here, right away, when you source NodeMan, I have to bump up the number of open file descriptors, and you could, in theory, just go change this or have it depend on a configuration file. But yes, I haven't seen any real problems with CPU or memory. Really, the parallel commands are pretty small, and the tools that they run are pretty small too. It's mainly, this open file descriptor.
Another
You can,
question. Go ahead. Finish
I
your
was
thought.
just going to mention that you can do a fan out on your parallel command, just like clush or pdsh. So you're not running more than, say, 50 at a time or 100 at a time.
So the extra question, it was labeled as a little bit off topic, but what was your experience migrating from to Werewolf from Bright?
It's a good one. There's definitely, it's more hands-on for sure. We chose not to go with like open HPC, which might have made it easier, but we have kind of an enclave wide idea of how we want to configure schedulers and other things that that don't mesh very well with one, kind of a, I don't know how you'd say it, maybe a vertical stack of 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 provisioning and scheduler and monitoring. So so we went with just bare bones Werewolf, and it was interesting. It's been a good move, I think, especially cost wise. I really enjoy it. I think I worked a little bit with Werewolf 3, but Werewolf 4 based on Go has been really good, and I like the way they do diskless, and I like the way they do overlays, and I like that they build their images with standard Aptainer or Singularity tools.
Nick, do you want to ask yours? You want me to read it?
Yeah, no, that's fine. I can read it out. I don't have to put the whole uh all of what I said, but what's next on the roadmap? What sort of features do you feel like you want to add to this still?
Well, whatever I run into is is for sure on the roadmap, but also maybe cleanup or restructuring. Like I said, you could reuse all this in a lot of ways, outside of just kind of the tactical. I'm typing it CLI. Um, so I think, reusing the functions, if you put a lot of effort into a function that does something that you really like, maybe you want to use it beyond uh, running it on host lists. Maybe you want to incorporate it into node health checks or that sort of thing. One thing that I'm going to do shortly just internally is push information to a database. So you know how I was mentioning you can just build a pipeline. I would have a command that is a wrapper around pushing say a problem state to a database, and that way we have a good log of these things, potentially across our whole HPC enclave, all, 5 clusters, 6 clusters, feed our hardware database.
It's got us close to time. Scott, really appreciate all the time and effort you put together by getting this ready, for entertaining all of our questions that we've gone through. Does anybody have any last minute quick short questions they want to throw out? So we're good, but with that, we really appreciate it again, time and effort, Scott, and thanks everybody for attending and adding to the conversation.
Yep, I hope this inspires people to, if not use this tool, but understand GNU Parallel and those tools better. Thanks.
Thanks very much, Scott.
Thanks, everybody.
See y'all.